and also from the engineering side, coding, designing, developing new things. But the next 45 minutes to 1 hour, I'll be speaking about how an algorithm which has been kind of designed and developed by a bunch of innovators, mostly from IIT Mumbai and IIT Delhi, been expanded to largely 100 plus countries, and also saving lives of many people. Also, as a background, I mean, before jumping into the actual presentation, as a background, you did mention about my acquaintance with the tuberculosis, and also working in the tuberculosis domain for a while. So tuberculosis has been classically diagnosed in one part of the segment of timeline previously by X-rays. But when newer tools like microbiological tests, when I mentioned about microbiological tests, it's essentially TB is caused by a bacillus called tuberculosis, Mycobacterium tuberculosis, which is actually a small bug, which apparently we need to establish any infectious disease by seeing it or culturing it or testing it for some biomarker, some identifications. But the absence of that, X-ray has been the main pivotal tool for diagnosing tuberculosis. But when the microbiological test came into play, X-ray got deprioritized. But later, the tuberculosis community realizes they are not only relying on microbiological tests. The tests available are less sensitive. Many patients may not be symptomatic. Many patients will have subtle disease. So there is a value of X-rays. On the same side, typically the government's design tuberculosis care is along with their health service delivery. So those who are coming to the health system having symptoms or signs of TB has been asked for tests for TB, offering tests for TB, which is, as I mentioned, sputum test. So essentially governments are delivering TB care in a passive mode. So that also did not help a lot in curtailing the TB epidemic. So globally there was a push for doing actively searching for TB. So how do you do actively search? You go and ask people, okay, do you have cough? Do you have fever? Or a bunch of symptoms will be there. That also worked, but again, it's a lot of effort. People going, it's mobilized a lot of health workers to go and do this search and collect sputum samples and test for TB. But again, as I mentioned, the X-ray has been a very sensitive tool. It's not too specific to diagnose for TB. X-ray also throws up other shadows in the lungs. It's a lung screening easily available imaging tool. So essentially, when on the same side, on the same time, there was actually engineering efforts done to make the X-ray machine tinier. So earlier it was bulky. You might have seen in hospitals there is a dedicated room for X-ray where you get into. There are bulky machines are there. So that machines have become tinier and become portable and become ultra portable. When I mentioned about ultra portable, it is actually 3.5 to 3 kg is the weight of it. So you can actually hold it like a digital camera in your hand. So essentially, the tinier machines, when the machines become tinier, it also addresses the mobility aspect of healthcare delivery. So healthcare delivery is positioned in a health center because we cannot move all the tools to the community. So this addressed the moving, coming closer to the community. So then who is going to read the X-rays? That comes into play. So people started taking X-rays, but again, it took almost 3 months to get an X-ray read by a radiologist sitting in a center where this screening were happening in a rural area. So there comes the value of artificial intelligence, enabled X-ray interpretation for TB triaging. Triaging means it's a screening test and also flagging a probability. This could be probability TB or not. So that's a broader context, and so I thought I'll bring in that context. Why this is important? Why AI is important for any screening test for that matter? Largely because of radiology images are interpreted by, as of now in our countries also, legally the signing of authority is a radiologist. And radiology is one among the health human resource which is very, very scarce. And given the radiologists are already overloaded with CT, MRI, and other high-end scans, there won't be much bandwidth for a radiologist to be sitting in a van or a ultrasound X-rays to go to the field and read an X-ray. So it actually fills the gap. The AI actually fills the gap of a skill set, which is high-end skill set, and also make the decisions easy. So easier for a frontline health worker who is initiating this screening and then take a quick decision whether to collect sample or not. That's how it has been designed. So I'm going to tell the story of Cure.ai, which I mentioned about. It's a startup started in 2016, and they focused on health. So why they felt focused on health is that data availability in health, and particularly in the lung health, because X-ray availability, X-ray image availability, both open source, downloadable, and also purchasable data available. So you all know that data is one of the key steps in designing and developing algorithms. So data availability become a key bottleneck in designing things, in developing any algorithms. So here the conclusive factor of it is there was data available. And once data is available, who is going to make the data, curate data and annotate it, right? Okay, so you are to, because this data is going to actually play a critical role in your algorithm feeding. Okay, this is a true TB or a true lung X-ray. These are the abnormalities. Someone has to annotate it. So there are radiologists available to annotate it. So this availability itself is a key function in designing algorithm. And again, so who's going to buy it, right? So when you design, so why I'm emphasizing on this on a buying side, because I in my previous stint and the current stint also, I'm exposed to multiple algorithms. Because the similar algorithm will be there, at least 10,000 algorithms of similar kind will be designed by multiple IITs or academic institutions, but they don't have a pathway to scale it up. So as an academic, maybe a classroom exercise or an assignment, we can do it to excite. But if you don't have a clear pathway, because there is a pressure on Cure to actually have a clear road to market pathway. So that is where then we also need to think about, when you design something, is there a buyer outside it? So and within that buyer, what is the buyer buying? Is the buyer buying X-ray machine or X-ray? What the buyer is addressing on TB, or buyer is addressing on other lung health issues? So fortunately, in the tuberculosis domain, there are global funding agencies under the UN, which actually enable countries to purchase, because there are 30 high TB burden countries. So these 30 TB high burden countries are also supported by this global fund or similar funding institutions like a World Bank or Asian Development Bank or Gates Foundation. So similar funding, and USAID in the previous stint. So then there is a buyer, you have a product, you have data. So I think all these things actually go hand in hand. So this is a brief background. So we work on advancing health equity, and this is the most deployed healthcare AI solution. Why it has become most deployed? Because X-ray is the most undergone. Most available imaging technology in globally. So it's roughly estimated around 4 to 6 billion X-rays happens every. In India itself, around 100 million X-rays are happening every year. So it's a massive at scale available. So anything you work on it will, any solution you're putting on it will have a massive impact effect. So as of now, as I speak, it is actually 100 plus countries it is deployed. Critically, in India, around 500 sites we have deployed. Mostly in all LMIs. Is why I'm emphasizing on the low and middle income countries, because that is where the public health issues are there. In developed market, there are other clinically challenging issues are there, whereas in this main places, the critical challenges with the uh, just 1 second. critical challenges with the public health issues, primarily by like a tuberculosis or other lung or silicosis lung cancer issues. And there are 4,000 plus sites we have deployed. The next slide shows about this. This is the product portfolio that we have. We have solutions for. So one thing you need to notice, as I mentioned, there are 1 billion, 1.5 billion images we have. So all these images are primarily for training. We are actually sourced through collaborations with the research institutions, or we are procured from data selling agencies, or from a contract when we are deploying. It's a special contract with the deploy when we are deploying in a live situation. It's a research contract wherein we clearly define these are gaps in my algorithm we would want to optimize, and then run source some images which is specifically with the consent and all these things. Otherwise, in a normal deployment, or when somebody purchases the algorithm, we are not allowed to make that the same data set to use for algorithm optimization. Just want to be clear about it, because this will, when we actually having conversations with the government partners, especially, this come across as a critical question. So they always would want to keep the algorithm price free, thinking that we are providing the data free for you. So that is so just keep this thing in mind. This will come across when you guys are also developing something. This will come across as a critical question to you. So I'll just reiterate again. So folks, government specifically think algorithm vendors will take away their data. What is in there for us? Like, you are anyway taking away our data. So why would we need to pay you for this thing? So just keep that in mind. So and if you can see that the range of offerings that you're offering. So primarily, I'm going to touch upon chest X-rays only. That's a good story to listen from an innovation, from a proof of concept to scale and policy adoption widely. We do have chest CT scan and head CT scan, and also musculoskeletal. The head CT scan is primarily for US and UK market. That's not for, I'm just saying anyone can use it, but again, primary adoption, what we are seeing in high income markets. The left side, what you see, the tuberculosis, lung cancer, and heart failure and COPD are from a single solution, which is a chest X-ray AI interpretation, which I'll come into the details of the product a little bit later. But just wanted to say that it's just one solution, but again, multiple diseases. So that's also important in a global health, when you are working in global health. Primarily, the global health is being paid by the domestic health budget. So, for example, in Government of India, NHM is the one who is procuring any tools, like any diagnostics tools, and deploying it. So, if we restrict it to only one disease solutions, there is a scope for getting less traction from any buyer. So that is where we also design the tool, go beyond a single disease and have a larger interpretation and also value addition for other diseases. And that's the constant journey. It won't stop there. It keep on actually happening. And we also need to respond to the donor needs, the country needs. Sometimes we collaborate with pharma companies, so they would want a different solutions based on the existing product. So that's an iterative process. That's not going to stop by saying, oh, that's it, and then it's done and dusted. Scientific publication is another important thing especially if you would want to have a global presence. In India, it's more of like you don't need to get into an extensive scientific publication, but though ICMR warrants any AI tool to be applied in a live patient setting, we need scientific publication, but they're not so super strict on it. CDSC approval also, I would say, given that we have all the documents submitted, it's not as rigorous as any other scientific process. FDA is the most toughest rigorous regulatory approval process, where in a lot of scientific publication from the local context is important. C is again a critical scientific process for the European region. Why it is important if you are looking for FDA and CE, that is critical for any WHO validation. So how it functions is that when you generate evidence by deploying it in different geographies, and you also have certifications from FDA and CE, that evidence will get revalidated by WHO for global policy shaping. So that's important. So if you are looking global, then it's almost always good to have that thought process, and also think about regulatory upfront, because many of the startups which I have seen, they focus on the product capabilities and the engineering capabilities, and also invest on making it super accurate, but don't think about how are you going to take it to to globally. So if you start in the midway, you probably miss out the opportunity to take it globally. And I would strongly recommend to have a regulatory thought process upfront when you have a minimum viable products. Just wanted to mention that this is split of, there are 200 employees, 100 plus AI scientists and engineers. So there is a lot of engineering and R&D efforts goes into this. This I covered, but again, this regulatory process is something which is going to help any innovator to have a space in the global health market, or even the developed country market. So CE is essential for Europe. FDA is essential. So once you crack all these two things, it naturally unlocks many of the countries. So every country have benchmarked FDA or a CE as a critical benchmark to offer a waiver for the local country regulatory approval. So just keep this thing in mind. If you are planning to do something, invest on this, have skill set inside your team, or have it outsourced or insourced in whatever way you would need regulatory skill set with the team to kind of help you in getting that evidence generations. WHO evaluation will become critical when, especially in the public health setting, and also if it is funded by global entities like, as I mentioned, Global Fund or a USAID or a World Bank. So they always look at WHO pre-qualification or WHO evaluation as a critical step to give policy recommendations in align with an AI tool. CDSA I just mentioned, and there are nuances in all this, and not getting into the regulatory nuances, because people will loosely say it is FDA approved even if they apply for FDA, but that's details of this thing beyond the scope of this presentation. So in the picture you see a person is holding an X-ray. Are you seeing that? Are you with me?
Yes, Doctor.
Yes, sir.
Okay. So do I need to pause, or like do you need any clarification now, or should I come back later? So how do you want to do it? I don't want to bore with a lot of voice from my side, and then.
No, sir, it's perfectly fine. Just one request, that if you can make the slideshow in a presentable mode.
Okay, this mode, right?
Yes. Now it is perfect.
Oh.
And in fact, it is good to get such insights, because in academia we don't get to know such things. So it's good, sir. No
Yeah,
problem.
no. I mean, I also felt when Basant was mentioning me to do a presentation, and also he mentioned about the theme of the conference, I clearly felt I'm an outlier. I won't fit into this thing. Then I thought I will tell the story of how an AI algorithm need to be deployed, what all considerations need to be there. Because many people, when people will come to us for some suggestions or recommendations or some advice, and so they clearly focus on their domain, but they don't see how it fits into the market. Like what are the what constitutes for a product to be market fit. So that is something
Yes.
which is missing. So I thought I'll mention that.
Yeah. So that is why you're not outlier, but in fact you are a perfect match.
Perfect. Thanks for that. That's so reinforcing. So as I
Right.
mentioned in the initial, my monologue, you would have seen that I mentioned about tinier X-rays. This is the best example of tinier X-rays. You see, this is a US manufacturer. This X-ray is now in the space shuttle also. So this they use for inside the space, the same brand. Made for US military for point of care X-rays. But I mean, apparently it got repurposed for the same use in tuberculosis. So why I am mentioning this, we took that to Everest Base Camp, and we made sure this function in an Everest Base Camp situation. Why it is important to mention this here is that when we think about deploying anything in a health system setting, you see a city like a Mumbai, and you also see rural places in Chhattisgarh where there is no patchy internet, forest, where patients exist and people actually live. So if you would want to take your health services to that remote area, how are you going to deliver that health services? So if you are positioning something as point of care, does it functions only in point of care in a particular setting, or in point of care in a much more plural setting? So that's the question here. So you see, I mean, we demonstrated functions in Everest Base Camp. That doesn't mean without challenge. So we have seen that we have done it in remote nomadic population in Nigeria, where in a desert, in islands in Indonesia where nothing exists, and Philippines similarly, with a lot with patchy internet or offline solutions. So we have done so. We learned a lot while deploying from an online system, a web-based system, to an app-based system, to an online system which works on good internet. I personally has been one of the early adopter of Cure when I was in Path and deployed it in Nagpur, and learned a lot. I mean, it was actually mutual learning for Path and Cure. Cure learned a lot for actually making this software. The Cure talk to the modality software, and also some wiring to make auto push happen. Then they also design something called a care coordination, which I come to that. Then they kind of compress all the, because many places there is no internet, so they have to actually have all the algorithm running in an offline QBox setting, which they call QBox, which is a compressed CPU. So in that journey, when we deployed it in Everest, what we realized that the computer was not booting, so it need to be heated up. So in that high altitude, low temperature setting, also there are challenges, right? So if your technology need to be that end-to-end to make it function in many of the public health settings. So this also, so as this mentioned, that WHO recommendation was critical to make this shaping the policy to enable to get it procured through Global Fund. So Global Fund annually spend around $3 billion for support to TB. By and large, for 22 countries, they support. And on the top of it, there are USAID also spent significant chunk of money for tuberculosis. So all the 2 to 3 billion is not coming to cure, but again, I'm just saying that's a portfolio. But screening is a critical element of before getting diagnosed. So this is some deployment experience here. So typically, this has been used as an active case finding. We also see it in the passive surveillance mode. So when AI came into the TB domain, the major use case defined was, now that we have this portable and ultra portable X-rays, there's a clear requirement for a AI tool to act as an assistant for reading X-rays. That was a clear thing, which is very evident. But people are using that for ages. But in Mumbai, the city TB officer, which is in charge of full Mumbai corporation health services, she decided, okay, she felt that there is many X-rays are happening in her facility. Roughly around 100,000 X-rays happen annually in public health facilities. Minimum. This is in selected 7 public health facilities, which you selected for a project. So she said her feeling was, my doctors are missing many TB cases. Can you make the algorithm run in the back end, and regardless of the recent X-rays being taken? I know in this crowd also, in the webinar also, we would have gone through X-ray in your lifetime. That's the most common tool available for imaging, as I mentioned earlier also. So X-ray has been taken not only for TB. It's for if you go for a health checkup, if you go for you had a fall and then there is a surgery. So all these multiple other reasons other than your lung health, X-ray will be taken. So she felt there is an opportunity to run the AI at the back end and see whether this is adding value. And incidentally, so this is actually incidentally picking up TB cases, and by surprise, 35% of the 30% of the cases she detected was incidentally detected. These patients came for some other reason and then detected as tuberculosis. There is an overall increase in TB detection. Now, every country where we having a conversation, they are inclined to switch into that model. So this is powering existing X-rays with AI, because doctors are not standardized. If I am an ordering a chest X-ray, I usually look at the chest X-ray and make a decision. So it's a test ordering doctor's tool, and I have different moods altogether. So I might be super precise in making decisions in the morning. Probably my decision making capacity or even X-ray interpretation capacity might go wave across the day. So AI being a standardized tool can work 24/7, look at all the X-rays and give a standardized report of disease of interest. If you would want to know about TB, you can pick up TB. If you want to know about lung nodule for cancer disease, you can look at that. So, so there is a use case within the hospital also. That's a primarily the message I would want to convey. So the left side, you can see a lot of graphs are there, is essentially validation. So any process, any algorithm which we develop, I think you guys are well versed in that. I'm not going to waste a lot of time. Internal validation is important. That will excite you whether your tool is working or not. But external validation is paramount for getting this into a good market, and also investors for that matter. So as I speak, we have 200 plus peer-reviewed publication as of now. So which is important to make it click uh, uh, your pitch credible, your whatever you are making claims credible to an external world, and say, hey, this functions well, and we validated it, and also external parties when they deployed it validated. So one, as a product, we can always say, okay, can you see my screen?
Yes.
Yes, sir. Yes, sir.
There is some goof up with this WebEx app. Suddenly the screen vanished from my screen, and you guys can see it. Okay. Anyway, I have to figure out how it can come back to my screen. Oh, okay. Now it is back. So okay, I'm keeping on talking, so you can see the screen. So it's beyond. One is the algorithm, which is, so we sell it in a license-based model. According to the country's requirement, there is a specific fee for it. We also need to crack. There are global procurement platforms like a e-platform. Like in India, we have an e-platform of procurement of of health solutions. I'm forgetting its name. But similarly, globally, there are procurement platforms like global drug facilities. There is a PFSCM by Global Fund. So similarly, many purchasing agencies have set up platforms. We need to get into that platform to get it purchased by the vendors. But that's one part of it. So once you buy, you also need to make sure that this functions in a difficult settings, whether they need offline, online, when it is deployed, post-deployment service also. So why I am emphasizing this thing, many academic institutions, including Government of India institutions and government make algorithms, and they're proud of it. And they will say, oh, we don't need any private party's algorithm, this is free. It's an algorithm, I would say it might outperform or maybe matching with the performance of a private party, but it's not deployable, because deployment requires a lot of other efforts. as I mentioned, starting from a regulatory clearance to actual engineering effort to make it function in different settings of, let's say, patchy internet to a high-speed internet. So now, as we speak, we are also having a collaboration with the Starlink. Now we are exploring, because any offline will comes with a high-spec laptop, and that comes with cost. And any laptop shipped from India to a remote place in Nigeria or a Kenya will also, who is going to take care of it? So hardware also comes with a lot of other issues, like starting from theft to going getting it damaged. Someone has to repair the hardware besides the software. So our mission is to make it offline, online, so that we can save a lot of customer service cost. So essentially, our positioning is not, okay, we are a software vendor and it is done and dusted. It's not like that. It's heavily we need to engage with the health system to make it running. So it's more of a partnership for a longer period, and that partnership also have something of joint evidence generation. So if I'm a national TV program of Kenya, if I'm deployed in, let's say, 100 facilities, our team also offer helping the synthesizing the knowledge coming out of it, and help them in writing manuscripts, which in a way helps us also. Again, I'm re-emphasizing this thing is academic student get out when you're into entrepreneurs or into startups, whatever it is. Also think through that how we can grow and also help others actually capturing evidence, because this is very true in any global, any governmental, and specifically in health. Evidence is critical for policy shaping and also be relevant in the domain. So uh, just want to emphasize that. So I mentioned about the algorithm part. So, and I did mention about my personal experience with Cure on Nagpur. So left side is the product. What you see, the left extreme is the product, wherein this algorithm helps in. So I'll just explain. So I'm going to get an X-ray done. Once the X-ray done, the modality of the X-ray gives an output in a digital, as a digital output, which is again a software giving a digital output, right? So our software need to talk to that software to capture this image and run in our algorithm and give an output. That's how. So the modalities, let's say if it is a Philips software, a Fujifilm X-ray machine, or a Min X-ray machine, or a Siemens X-ray machine, their output become our input for our output. So that's how it is designed. So there has to be a seamless data flow from that modality to enable our algorithm run it. So that's a prime first step to get it done, which also come with engineering efforts. Our engineers need to talk to this modality partners, engineers. So they will have API or other type of integrations. There's an effort involved in that. So if you would want to go to market, you also need to look at who are the market leaders in your, because you have a hardware dependency, right? Who all are your OEM providers, how we can what kind of relationship we need to have, what kind of integration we need to have, all these need to be thought through. So you have an output as an X-ray interpretation, how it talks to the health system. So you correct one thing, right? I am a doctor sitting, let's say in a district level, this screening happening in a panchayat. How will I make sure this screening, the screened images interpretation coming to me for a decision making? So that is where a care coordination application is important. Either you do it or you integrate with the existing care coordination application. This is this is, you might have experienced that when you do a lab test, the lab result will come back to you, and also same lab result will go to a doctor. When you show up in the hospital, the doctor will have that result in front of them. That is actually LMIS, Lab Information Management System. Similarly, a radiological information management system also exists. So we are forced to develop something called QTrack, which is again functions on a web application and also on a mobile. So if I'm a doctor sitting in a district hospital and screening happening in the panchayat, I can actually view that image as you see exactly in the PowerPoint. And it also says that there is an abnormality. So what the algorithm does is that it calls out whether the X-ray is normal, abnormal. That's a top line. Then it also calls out if abnormal, what is that abnormality? and also demarcates. You can see that demarcation. So if I'm a doctor and think something is falsely demarcated, I can have a second look at, oh, this is an area where the abnormality, I can actually switch my gaze into that part and then reconfirm it. Or I can say, okay, so this is largely normal. I don't need to invest a lot of time. So because algorithm is optimized for normal abnormal also. So on the other side, this Q track is care coordination application also give me, so my district medical officer is probably, I mean, most of the places district health officers or CMOs are essentially administrative doctors. So they they look at how many TB screening happen, how many malaria tests happen, are they on track with my target set by Government of India. So this enables also to have aggregate dashboard at the local level or at the country level. So lot of capabilities. So this any algorithm getting deployed is not that easy. That's the message which I want to say. Partnership. This slide mentions on the focus on the partnership. You have a different, I mean, wide variety of partners, starting from academic partners, global partners, evaluation partners. There are partners who evaluate such technologies. Find this an example. They deploy also, they evaluate also. Path is an innovation facilitator, which actually scout innovators and collaborate and fetch funds for testing it out in the field. There are private medical partners like Group, Helios, Radaid. All these are actually private uh, health aggregators. Say these are platforms which they enable other platforms to come and rest, and then people can get purchased, or they been collaborating. Especially telemedicine and teleradiology services is another way they utilize our. There are population health agencies like a Stop TB partnership or a McGill University or FHI. So they deploy this for public health this thing. And there are pharma, which is AstraZeneca, Johnson and Johnson, Medtronic, Viatris. I'll come back to that, how they are using. There's also the hardware partnership like Siemens, Philips. I mentioned all this. So partnership is also important. So the takeaway from the slide is not about the individual names in this thing. You need to have a wide variety of partnership to make a product successful and scalable. I mentioned about the evidence and the number of papers which we developed over the period of time. But also, what is important to make it a compelling case is what is it cost your at what cost your technology is being helping the patients. So you would have heard about robotic surgeries, right? Okay, so now it's a boom. So if you have a prostate cancer, need a surgery to be done in a government hospital or in a private hospital. Sorry, it will cost without a robot high fancy surgery in a middle level hospital, which is covered by PMJY. The cost will be around 35,000 to 50,000 maximum Indian rupees. If you would want to opt for a robotic surgery, the cost is 5 lakh Indian rupees. So that's the cost dividend, right? So if somebody has to make a policy recommendation, they also need to look at, hey, am I making a policy recommendation which is going to help the patient in surviving? So for example, in the case of prostate cancer, what is the additional advantage I am going to get by spending 4,50,000 extra through a robotic? Is it 6 months survival or is it 5-year survival? So that makes a huge difference, right? So that is where the importance of health technology assessments comes. So Government of India also have a health technology assessment system in place where ICMR, Department of Health Research, facilitates that. We don't need to do anything. We just need to apply for it. Government of India identified institutions are there. They do it on their own. Similarly, every country, most of the countries have health technology assessment, and they made the health technology HTA as a mandatory step to get into integrated with the public health system. So here for our tool, there is a saving of 10,000, roughly around 10,000 Indian rupees uh, for each case additional detected. So what they did was they looked at existing pathway of disease, I mean of an X-ray reporting, which is primarily through an through a radiologist, and they looked at AI reporting and what is the saving and how much additional cost you save. So if the government of India follows a radiology pathway, they are actually losing out 10,000 Indian rupees. Whereas if they follow the A-enabled pathway, they are saving this. So there are a lot of statistical nuances in that, but by and large, the message is that this is cost saving than an assess what is existing now. So that is an additional requirement from a health with respect to health tool when it compared to other tools. So health technology assessment is essential. So you also need to prepare for that. Okay, so if you can come up with fancy algorithm, but again, if is it adding more cost with less survival advantage or less cost with more survival? That's the question. So the other evaluations are especially deployment evaluations. They also evaluate. I mean, once they deploy, they also do a retrospective or a analysis with the existing benchmark with radiology and look at how our algorithm performs. So that's a constant exercise we do with external evaluators. Very recently, we also got evaluated again by our newer version, got evaluated by WHO, and we got it cleared. So just reiterating before getting into an algorithm in the productive healthcare algorithm, I mean, into productive healthcare algorithm, there are lot of other steps which I mentioned, starting from the data itself to model deployment. There is a user-centric design. Why I would want to mention about the user-centric design, if you go to an US, the user primarily doctors or a specialist. Whereas if you go to an African country, the users are primarily frontline health workers. They are less educated or less skilled health workforce. So what are you designing? So for them, they need, what they require is just a triaging tool. Okay, I just need a decision to whether I need to collect a sample from this patient or refer the patient. So you also need to look at whether your tool is providing output to help the frontline health worker. So that is where the user-centric design thing coming into play, especially in health. Regulatory, I mentioned about it. Integration, I also mentioned. So we need to integrate with both the modality as well as for healthcare systems software if it exists. So when we sell also, there are clients are primarily maybe one implementation partner will be there, but again further down there are facilities will be there, or even each machine is a client for that matter. So we also need to look at how it is getting deployed in each machine, how it is managed. Online is largely easy to deploy, but offline people have to shift the laptop and get into a Teams call and explain them this is how to make it functional. Sometimes we need to go physically because the other side folks won't have that technology know-how to make the things function. Then there is a customer support part of it. So it's slightly complex. Regulatory, I mentioned about the importance of it. I'm not getting the details of it, but just wanted to emphasize that anyone who is working on the health domain, please think about the regulatory piece well in advance. Otherwise, you are going to lose out. The other thing is partnership. So primarily public health is owned by government. It's a government's responsibility to make it happen, right? So you do have partnership. You cannot just disengage with government and make an impact. So if you don't want to scale anything at the scale what we have done, you need government as a partner. So these are some pictures wherein we have government, including Government of India. You see the Prime Minister Modi visited our stall, and he spent almost a minute there to understand what we are offering, and was very keen. And then now we are part of the Ministry of IT's best AI solutions. We got that award, and also we have been hosted in multiple such platforms. So all of these places you see government as a critical player. As I mentioned, this is awarded as best AI solution for global health in 2023. These are some spotlights. So where we are winning awards, getting a lot of prize from governments. Just wanted to mention whether the journey stopped there in one part of it or not. So as I mentioned, while we are deploying, we also learned. So I did mention about 100 countries. So 100 countries at different level of maturity with respect to digital health. Both regulatory, there won't be any regulatory process. The people are wary about cloud. People are wary about uh, AI. There's a huge scare about whether AI will replace human resource or not. So every country, when we work, there is a long process to make that awareness created, make that acquaintance created, and when we get deployed, also adoption, right? How do you make it adopt? Then we realize we are just opening up a range of disease into them. So as I mentioned, our AI tool can report chest X-ray. It's an X-ray reporting tool, and it also notifies certain diseases like TB, lung nodule with a malignant score, and few other bunch of lung diseases. But within that, when you open it up, how the health system responds. So health system say, okay, TB, I'm getting money for TB, government is supporting, I have drugs, so I'll treat TB. What other things I can do for the patient optimal? I'm not sure what I can offer, right? So we realize that there are a bunch of other technologies also available in the market, which are all AI driven. So we felt how can we create an AI driven digitally enabled care pathway for lung health, at least starting from our product, helping governments to think in a direction which is much more efficient, digitally driven healthcare delivery with high quality and with less human resource, because any test and point of care. So you see a lot of innovation named here. So I'll just take a couple of things which is relevant here. Swasa is an Indian startup which helps in characterizing your cough. And I'm saying when I am coughing, the Swasa application will say whether the cough is normal or abnormal, cough is a COVID or a TB, and while from the cough itself, it gives an output about of your lung health. Not super accurate, but it's a signal. When I mentioned about lung health, it gives lung function test. That could be a trigger for an X-ray. Let's imagine if I'm walking into health facilities, somebody is asking, can you cough? And cough is, oh, your cough is abnormal. Now you go and get an X-ray. Oh, your X-ray is abnormal. Let me just test for TB. Oh, your TB test is negative. So you're still coughing. So then we can offer AlveoFit. AlveoFit is again an Indian innovation, which is a handheld spirometry device, AI-enabled output. Once I get that, I can also see, okay, my lungs is, I'm an asthma patient. Okay, now I need monthly my lung health checkup. My doctor will offer a swasa. You cough every monthly and see your lung health is getting better. I'm on drugs. I'm on inhaling drugs. How do I make sure whether I'm taking drugs or not? SureAdhere is a tool which enable AI-driven adherence of it. So essentially what we're trying to compress and bring in all the tools and leverage AI and digital capability into create a lung health pathway than a TB pathway. So just think through that also. Don't try to solve one health issue. Think about a little bit more from a health system, what all challenges they face and how can we leverage technology for solving it. So clearly, there is a lot of mismatch. Those who are following global health can always see there is a lot of the need versus what is supplied. There is a huge mismatch in that, and which reflects in the funding part also. So, and many critical challenges, there is no health human resource. You know that we in 2000s we came up with the concept of ASHA. So now ASHA become overburdened. So we probably need to come up with another bunch of ASHAs, sub-ASHAs or whatever it is, right? So health human resource is a critical, scarce human resource across countries. So and we also realize while in the journey of deploying our X-ray solutions, data entry is one of the key challenges. And many health workers are doing, so for example, in a community health center in India, in a primary health center in India, it's managed by community health officer. This community health officer have to deliver 13 different modules which are 13 different health segments within the larger healthcare delivery. That's a part of the response. So they have to memorize all these modules and then follow that module. So how do you do that? And also capture and maintain all the registers. So there are 32 odd applications for NASHA, or even for MNCH, one disease. It's a multiple solutions, multiple registers. It's all data entry dependent. So we felt, so now we are working on something called a, so how can we solve this problem? So given that LLM came into the picture a few years back, and then it's now redefining all the AI journey, we are offering now two solutions. Either through a passive conversation listening between a health worker and a patient, can we capture the relevant information for the health, and then pre-populate the health forms so that the registers are automatically populated. So, and also at the back end, you embed the country algorithm, country guideline. Not when I meant algorithm, country guideline, so that you are ensuring you are addressing two critical things. You're solving the data entry part, and you're also making sure this is the health worker is protocol adherent. This is now being tested in Rajasthan and in UP, and also in Rwanda, Uganda, and Ethiopia. So I will have more information about this thing in the coming months. About deployment. We are also looking for joint partnership with the government to fetch funds from Global Fund and Gates Foundation. So, which we name it as an ERA, which is a co-pilot for AI for health workers, primarily data entry through multi-modality. It can be a picture capturing of a raw form. It could be an audio-enabled passive form, or it could be even a video capturing of a form also, multiple forms also. So I'm just stopping there. Just wanted to kind of thank you once again, and then want to get into the conversations, or I'm stopping sharing.
Okay, Dr. Shivu, that's.